Hello everyone, welcome back. I am Ruksar Hedri and today we're here at Pravesha Industries and I'm super excited to take you through their production process, their state-of-the-art infrastructure and so much more. Come, let's go. So we have Mr. Sunil Kaul with us today. Hello Mr. Sunil.
Hello Ruksar, how are you?
Very well.
Pleasure
Thank
meeting
you so much for having us
Pleasure
here.
you be here.
Likewise. Well, why don't you introduce yourself to our viewers first?
Hi everyone. I'm Sunil Kaul. I'm working as a Vice President Operations here. I've been in the industry from last 20 years and my previous experience is about more than 30 years. I'm an engineering graduate by profession and technically taking care of all the units of profession. Thank you. Let's move in and have a look at, let's go and have a look at the facility.
So Mr. Sunil, meanwhile we proceed, can you just tell us how this entire process started?
Yeah, I'll give you a briefing about the journey what we have gone through, and this all started as a Pravesha. You can see name itself is a part of Sanskrit. Pravesha means a gateway for a packaging solution. So this gateway we have started somewhere in 1999 for the bulk packaging, where we used to pack all in drums like 40, 30, 50, 65, 120, like these drums in various colors and various sizes. And over the period then in 2005, we started a secondary packaging in the printing area, printing packaging where the mono cartons and leaflets. In 2006, we went to primary packaging, bottles. In 2009, we started labels. 2010, we started CR and non-CR caps. Our CR is a patented cap which we have developed specifically for our utilization and usage.
Wow.
2012, we went again improvised ourselves. We went into aluminum packaging for the blister pack and all. Slowly, we are further expanding in different packaging field and all and moving ahead. Let me explain you a little more while we'll walk through our facility.
Sure.
As we have, please come in.
Thank you so much. Wow, this looks like a beautiful corridor. Where exactly are we going, Mr. Sunil?
I'll be taking to the manufacturing area where we say a process area, like you're saying, where the production takes place.
Okay.
For different sizes of bottles are made and all. As there are two kinds of types of processes. One is injection blow molding, other is extrusion blow molding. Let's enter into the production area, please.
Right.
One moment.
Yeah.
Please come in.
Thank you so much.
Here you meet Mr. Harish.
Hello.
He is taking care of production area and all, plant. So here we need to have a gowning facility as we are entering into the clean room area.
Hygiene first.
Yeah, it is a total, as per the ISO standards, we have to have all the gowning change over and all.
Okay. Oh, we really are sticking to quite some standards
Yes.
and hygiene.
Yes,
I really like that.
You need to fulfill all the norms of clean room.
Wow, this
have
looks
to go
like an
through-
exciting area.
Yeah, you need to go through a lot of locks and all. Now this is the passage you need to walk in. This is the process which I was explaining you. It's called an injection blow molding machine. So I'll just explain you on the machine how the flow of material and how the process is made.
Right.
Let me cover this. And you can see the pipelines over here. So the one pipeline caters the raw material, resin, in the granular form. The other pipe caters the vacuum. So that with that vacuum suction, the material moves into the hopper. This is the hopper and this is the mixing unit. Here you can see a white color granules here.
Oh yes, there.
Yeah, this is called a master batch. So master batch with certain dosage gets mixed over here and there is a stirring unit here in the bottom one.
All right.
It goes into the feeding unit. Now if you see this, it's called barrel.
Yeah.
Barrel is connected with number of heaters. So When it goes into the feeding area here, the material turns inside internally with the help of a screw which is helical in shape. So it has three zones: feeding zone, compression zone and the metering zone. So it passes through all the three zones. Then I will show you.
Yeah. So basically, this is where the bottles take shape.
Yeah, here the material, how the material is uniformly mixed and then injected into a mold where it processes to the blowing and the bottles are coming out.
Oh, I see them coming out.
Yeah, now I'll show you how the process takes place. As I explained you, material is turned and brought. Here's the injection unit
Okay.
where it fills the mold with the molten material. It will come in the form of preforms. Preforms will go into the blowing part where it is blown with a compressed air at about 13 bar pressure. These bottles are formed inside to get the shape and size of the cavity. Then it is ejected out.
Okay.
Yeah, now you see it is ejection. All bottles are filled and come out. Then it is ejected as a bottle.
So is it going inside for cooling or it's already cool?
They are automatically cooling and blowing it taking place.
Okay.
So both the things are happening inside.
Understood.
So after passing from here, it goes into the inspection area. This is the inspection area we have,
Okay.
where bottles are passed through this inspection, where it's with the visual inspection. We have a top camera and the bottom camera. It takes care of various categories of defects here. So all defects is detected and monitored inside, and then whatever is defective, it goes through into the rejection bin. That's the rejection bin. Rest comes to the OK bin.
Okay.
Similarly, we have all the machines running here, and we are catering around various sizes over here. Let me take you over the complete line. As I explained you about the machine,
Yes.
and the output comes out from this machine after inspection, then it is packed at a different pack sizes and all. Let's move.
I can see there are also bigger bottles being
Yeah,
produced.
we have a bigger, all sizes of bottles which I told you. So we process different sizes. But the cavitation vary size to size. Smaller bottles, more cavitation. Bigger bottles, less cavitation. Let's move.
Let's go. So you're producing the bottles here and simultaneously packaging them here and then sending them to the warehouse.
Everything is closed here. Because as it's under the clean room facility, we have to close within this thing. We cannot open the package after this.
It's a hygiene seal basically.
Yes, hygiene thing you have to be. So everything, so if you see, the material is also coming through the closed line.
Right.
Nothing is open, no manual intervention is there. Everything is automatically done. So as I told you, white color, we can have different colors as per the customer's requirement. We are running blue color also somewhere, so other colors also can be planned accordingly.
All right. So how many machines do you have in this particular unit?
This is approximately 58 machines we have
Oh my
in this
God.
particular block.
All right. You need 2 manpower to handle one
Yes,
machine.
2 manpower for handling the packaging, everything.
Okay.
Please.
Thank you.
So machines are placed in such a way, so every machine has a equal distance space
Right.
for any changeovers, for any kind of a material handling and all. So that's why we planned it. So we have different machines on both the sides of the unit. As you can see, is a conveyor.
Oh yes.
On the other side of the conveyor also we have the machine. So this area is connected with two conveyor, which is a centralized conveyor, and it takes the material to the finished goods area. You can see the length of the conveyor up to the
Yes.
end.
Till the end.
Yes, it's up to the end.
So
So-
is it a central conveyor belt?
It's a central conveyor belt.
Wow.
It is automized with the vertical conveyor in the FG area, which I will show you on while reaching to the FG area.
Sure. So Mr. Sunil, how many bottles do you manage to produce in a single day? Considering we have so many machines inside one unit.
Yes, that's a good question you have put across. See, the number of bottles depends upon the width size. The smaller the size, as I told you, is the number of cavities are more. So with the number of cavities are more, output will be more.
Right.
So if I running more number smaller bottles, output will be more in a day than the bigger size. On an average, you can say I make approximately around 10 to 15 lakh bottles a day.
Oh my God! The supply indeed for these bottles is huge then.
Yeah, overall in a month, I make approximately 3.5 crore bottles in a 35 million bottle.
Impressive.
Please.
Sure, thank you. This is a medium-sized bottle.
Yeah, medium size, bigger size also you will see. So these are all all machines are automatically handled
Right.
by internally programmed such a way that they just have to feed the program, it automatically starts or without changeover of the mold.
Right.
As I showed you inside the machine, there are three sections: injection section and the blowing section and the ejection section. That's a part of the changeover.
So basically, most of this process is an automated process.
Yes, we have to, it is automatic process with the programming. So I wanted to explain you, each box after it is getting packed, it is labeled with a small label. This is called a production label which has a 2D code on it,
Okay.
kind of QR code.
Yeah.
So it gives the complete history of the product, which machine it is made, what are the batches we have utilized, and which day it is produced and all.
So
So
it's basically
this is the production label.
a
It
history
gives-
track. Of
It
the
gives the
product.
complete tracking of the product, traceability you can say. After this, we use the product label and the customer label at the time of dispatch. Rukhsar, now as I told you about the machine, this is the complete area is called a IBM, injection blow molding area.
All
So
right.
second, after this, I will be taking to the extrusion blow molding area. Let's walk.
Sure. So there are two types, EBM and IBM.
EBM and IBM. So this is a continuous process IBM because the cavitations are more here and it's for the good production quantity required.
Right.
So we get per day very good quantity of production here. In EBM, we get a smaller production run. So we use EBM for that. So as we do the production planning, where the volumes are bigger, so we take it on the IBM. Where the volumes are smaller, we take it on the EBM. Let's move.
Got it. You have a lot of companies that you're supplying to, and no wonder you're actually meeting the demand with such production quantity.
Thank you, thank you. We are working towards for the much better outputs and all. As we have mentioned, our motto, we have a timely delivery and good quality to my customer. They should be satisfied at the end of the day.
I see that you're continuously evolving comes to technology and adopting those technologies to
Yeah, updating ourselves and keeping
Yeah.
things in the upkeep position and all. That's it.
So, thank you.
Things come.
Where are we going now? To the
Now I'll be taking to the EVM section.
Okay.
So I'll be taking to the EVM section.
Sure.
So these are all EVM machines. I'll show you the process.
Sure.
As I explained in the IBM process, it is similar way the material comes here and it goes into the hopper. From hopper, it is again mixed with the colourant, goes into the barrel.
Right.
Here, after this barrel is the process is different. There it used to go injection. If you see from top, you can see from this gap.
Right.
Here it is coming in the form of a tube, which is called a paragon. So paragon is taken between the two halves of the mold. It is cut with the help of a cutter. See the cutter cut. Takes to the blowing unit, where the blow pin is inserted inside and it blows the bottle inside with the compressed air. And the auto deflashing is there. See, it will deflate. Automatically deflate the neck. So as I told you, IBM is a automized process with the bulk requirement. EBM is a also automized process with a smaller quantity requirement. Suppose I have a batch size of 20,000, so I can produce here. Where the batch size is about 5 lakhs, 10 lakhs, I can produce in IBM. So we have, initially when I developed mold, I developed for EBM. Because initially we don't know how the requirements of the process. So slowly we moved to IBM.
Okay.
In EBM we have scrap generation too much. IBM we don't have scrap. You must have not seen the scrap there.
So do we utilize this scrap
No.
and recycle? No.
As it's a pharma bottle, no scrap is used. It goes it is disposed of directly.
Okay.
Please.
So isn't it quite a lot of wastage in EBM?
Yes. See, this is a convention process. So that's why we utilize this process very rarely as and when required.
Okay.
Otherwise, we use mostly with the IBM. And we have converted most of our bottles and products into IBM process. But EBM, one thing is very good about EBM, you can change over time is very less.
Okay.
Because only one mold is changed and moved faster. And second part is, here the setting time is also very less as compared to IBM.
Okay.
Because in that case, all the cavities have to set as per the and synchronize at the same level.
Right.
Here, one cavity at a time. So we can manage it faster here. As I told you, no scrap is used here. Everything is virgin.
Okay.
So it moves on with the virgin granules. As you in the feeding area you saw, virgin granules are fed. There is no place for granules, scrap granules and all. As it's a centralized conveying machine, it comes through the centralized conveyor system. So nowhere possibility of fiddling with the raw material.
So there's no scope for counterfeiting as well?
No scope for counterfeiting. I was telling you that this unit has different kind of product line, easy to change over and all. So that's what initially we planned with this machine.
Right.
Once the product is commercialized and it is fulfilled in the market, we are getting the commercial quantities, then we shift over to the IBM process.
So these are now blue colored bottles that we're talking about.
Yeah, that's what I was telling you. Here you can see the master batch uses blue color.
Oh, so that is itself in
That
the
itself is the color changing.
Right.
Where the color is not required, it will not be used. It will be stopped.
Okay. So Mr. Sunil, what are these bottles? This looks different. Is it an IBM again?
No, it's not IBM. It's called PET bottles, which is made as per ISBM. Injection press blow molding.
Okay.
Here I'll just explain you.
Can you tell us a little more about the process?
Yeah. This is similar where the material comes. Here the material is done a dehumidifier, which the moisture is removed from this thing. Then it is gone into the hopper, inside the hopper. With the master batch mixing automatically, it goes into the barrel. From here barrel, it is injected here. The injection stage here. After injection stage, there is a stretching. It stretches. Then the blowing and then the ejection.
Okay.
Here they are placing and making a matrix out of it. This matrix is then shrink wrap. I'll show you how it is.
What are these bottles used for?
This is used for the cup syrup and all.
Okay.
Pharma industry, cup syrup. You must have seen
Yeah, can pretty much
various
make
cups.
out the
Yeah,
appearance.
cup syrup for kids and all, they use
Yes.
it. It's like that. I'll show you the sink please. Then they put that tray from there. It will just sink fleet. I'll show you from there.
Yeah.
Okay, now he will put the tray inside.
So these are going in for inspection, is it?
No, this is going for hot blowing inside.
Okay.
It will get shrink wrapped here.
Oh. Pretty much everything that we see here is almost untouched by human hands.
Yeah, lock. Now it's locked. Then
Sterility
then it is cartonized and placed like that. Let's move.
Sure.
Look sir, I was showing you how they do the shrink sleeving of the bottles and all.
Right.
Carton. Now we have come up with a new technology. We are put everything through robotics.
Okay.
So it will be a robotic arm which we are installing. One machine we have installed. I'll show you the dry run of that. How the robotic arm picks the bottle and fix it and matrix it automatically, and it is shrink sleeve.
Okay.
That you can have a look properly. You can have a look this way.
AI has really come a long way.
Rukhsar, I was telling you we have gone with a new technology. It is a robotic arm here. If you see an arm kind of structure here,
Yes.
which picks the bottle and place it on the conveyor. It is under this thing, under testing and all this time, which has been recently developed under trials and all. So the bottles it will take position in the conveyor. Then the conveyor moves like this.
Okay.
Goes like this, and it goes enter into this table where it matrix. You can see the matrix over here. So it creates a matrix, and then we'll go back.
Sure.
Then here they will place a bag over here. What that manually they were putting up, here automatically it will be put.
So there is no human intervention at all.
Not at all. It will be automatically put, picked, placed, and shrink wrap, sealed also.
Where are you going now? To the
Now I'll be taking to the EVM section.
Okay. So, Mr. Sunil, when I was coming in, I saw a lot of greenery around, very beautiful premises. So, can you just take us through the entire greenery?
It's my pleasure to take you, as this is the main part of this premises, the
Yeah.
green area. Let's
Wow.
move. I'll
So
show you the
looks like, you know, Pravesha has built its own little ecosystem.
sort of like that. You can see we are working on that towards that. You can say.
Switch into greener environment.
As I was telling you about the green area and all renewable energy, solar, we have about 1 megawatt capacity and all.
Right.
On your right, you can see there's a rain harvesting pond also there, where the whole complete units, whatever collection of water is there, it is flown into that. And it is utilized as per the increasing the level of groundwater and all.
Oh, wow. I think I see a lot of mangoes also over there.
Yeah, a lot. This is on your left side also full of mangoes only. These are only mango trees.
Yeah, but I must say that the entire facility, the entire premises have been very well planned. It is not just beautiful to look at, but also when you come inside, the feeling, it's beautiful. And as you walk into the facility, each production process is so intriguing. I've had a very delightful day throughout, and I must thank you for taking me along throughout the day. And I really want to know that what is there beyond this part. Like, I've not gone to this
See,
side.
I'll tell you, still we have completed halfway. Still
Okay.
another halfway is there where I can show you my feeding part and all to the raw material, how the material movement is going on and all. As you are appreciating about this area and all,
Yeah.
we should thank our management. They have been a vision behind it. So they have worked hard together from the initial stepstone to now to this level. Every part they have been looking forward, creating their own sense of aesthetics. Greenery is their main motto and all. This is the entrance. Here we have a weighing bridge also, our internal weighing bridge. So all input material are entered from the gate. It is monitored with the weight, what is the input weight. Then they do the tier weight calculations and all. Everything goes to the store.
Right.
At that point of from the store, all the documentation work is done. Now we'll be moving towards the silo.
Okay, so I think we've almost walked a mile and there's no end to it. Looks like a never-ending way.
One more good part of this premises there, it has the all around a road.
Yeah.
Where a vehicle can move freely all around. There is no reversing, forwarding, like a lot of interceptions are not there. It is free movement.
Absolutely. This is very pleasing to the eye. I love the view.
During rains, you will love very much.
I'm sure.
It gives a richer relief to eyes and all. You may.
So this looks like an invite during the monsoon season as well. I'm definitely
Yes.
coming down and
Most
troubling
welcome.
you.
Most welcome.
Wow, I see quite some life-size silos.
These are the ones which I was talking you about, the raw material storage silos.
Right, this is the backbone of the entire
Yeah, so
industry, you say.
actually we are saving a lot of space in storing this. Otherwise, huge lot of space would have been taken for storing these raw material bags and all.
I'm sure. So what is the storage capacity of each silo?
Each is approximately 75 tons.
Okay.
Each, and total there are 18 silos, each of 75, around 1400 tons you can say is the capacity of total raw materials here.
All
So
right.
this is the storage we keep it, and
That-
everything is automatically fed. Pressure conveying is for feeding purpose, and then the vacuum system is for the transferring to the machines. So each machine will have its own transfer unit with the material movement. So it will suck the material as and when required by the machine. Now I'll be taking to you the automatic center where it's the heart of our all the utilities, where we control it to our maintenance department.
Wow.
Here is our maintenance section. If you can see, you
Okay,
see all
so
the
you-
controls.
Right.
So you can see all chillers, cooling tower, fan moving and all. You can get every indication here, which is working, which is not working, and how to stop it also we can do it here, program it here. So everything is automized here, and you have the complete controlling over here.
Right.
That's another SCADA for our feeding system. All the raw material that feeding, he is doing the raw material and master batch. He is controlling it here automatically.
Okay, so
That is also checked here, so that it's monitored. No machine is stopped because of this. So he has to keep the flow intact always. So these are the main heart of our utilities, you can say.
got it.
So you can say this is a machine, this is raw material.
That's brilliant. So I think most of the times, whenever something goes wrong, these guys are the first ones to realize or get to know something is
so
wrong.
where to act on it and all. So they immediate inform to the department so that they can reach to the site and get it corrected immediately on that particular point. They have not to search for it.
Right.
So time consuming is not, it's specific to that particular area to be taken care, and it's an immediate diagnosis
Yeah.
with the action on it.
So what are we up to next after this?
Now I'll show you the other part of which is quality control. You will have a much clarity what quality department does work over here. As you were questioning me inside the plant, what is the quality parameters you take care of.
Right.
So
The
this is
regulations
this is
and how
quality,
you keep up with
quality
it.
parameters, and what are the process checks and all. We do it in our quality department. This is our quality.
So now we're entering the quality control
Quality
room.
control. Mr. Prakash is taking care of quality,
Hello.
and we have some of the team members over here which perform the tests and all.
Right.
So like this is the test, what we call it an induction sealing test. So every bottle is induction sealed here, and we conduct this test here. After this test, we see any leakages are there or anything like that. We call it an induction sealing test. Aluminum foil is induced with the heat. The wax is there which gets melted and it gets tested here. Weigh test, weighments and
Of
all.
course.
There's a dimensional analysis like a height gauge we have at this.
Okay.
They conduct the height gauge.
Yeah.
So after induction sealing, we conduct the vacuum leakage test here. So this is a desiccator in which we create a vacuum of certain pressure, and then we keep it for 10 minutes.
Okay.
10 minutes, huh? And then see what is the level of leakage and all. Accordingly, you decide how the package is good and bad.
Okay.
Then
This one looks very interesting.
Yes. Then we do the brimful capacity. It's the overflow capacity, means every bottle has its internal capacity.
Right.
So we measure that internal capacity, here is water, and then perform at this test and record it. Then we have packing material also, we do scuffing, GSM. This is for the packing material. Then we have a furnace oven here where we do it. And this is a melt flow index, which actually tells us the rheological property of a polymer, at what particular temperature is going to create a flow. So this is very important test for any plastic industry. So that we keep a extrudate like that. This is a bursting strength. This is melt flow index.
So what does bursting strength do?
It is for the packing material, like it sees what is the thickness of that carton, that
Okay,
packing material and
okay.
all.
Got it. Like at
And
what
this is the
degree?
melt,
it bursts?
yeah.
Right.
At what degree it bursts and all. Ball bursting and all. You must have been knowing.
I have had.
So this is a melt flow index, which tells us. Then all dimensional parameters, record keeping and all, they do it here.
Wow,
this
so
is
you have like A to
small
Z quality
lab
check.
here for our
Yeah.
packaging material and all.
And in terms of certifications, where do you get your certifications
We
done
are
from?
we are certified with the primary packaging, that's 15378. Then we have ISO 9000. Then we have a DMF certified bodies are there. Then we have a GMP certified bodies. So these are all certificates we process it up for all the units, GMP units, you mean to say.
Right, so you're basically catering to all the global standards of
For the
quality
pharma,
control
pharma
regulations
needs and
in
all, yes.
pharmaceutical industry.
Food and pharma needs.
Right.
We are working on it. Please.
Brilliant, thank you so much.
Yeah.
So Mr. Sunil, we're done with all the processes, we're done with the quality check as well. Now can you also like show me the storage area? Where is the conveyor belt headed?
Yeah, that's what, this is the place we are heading towards the finished goods area only. Please come.
Yeah.
This is the finished goods area, and
Oh wow, this is massive.
it has a storage capacity of 3 levels, A, B and C. 3
Okay.
levels. Each level approximately stores, you can say about 75 to around 25 lakh bottles.
Oh my god.
75 lakh bottles in all the 3 levels. So that from center conveying, I come this way.
Yeah,
It comes here
right.
and it is moved on a vertical conveying system like this.
So where does it go up from?
It will go to
Right
all
there.
the 3 levels.
Okay.
You can see this is level A, level B and level C. So it picks like this, you can see from.
So are they segregated on the basis of their size and weight?
No, it is segregated as per their product size, yeah.
Right.
So it is coming at level A.
Okay. And from here they will be segregated accordingly.
So then it will go to a particular rack from here
Okay.
manually.
So but all the finished products are coming from IBM and EBM together.
Yes, together. So it will be automatically segregated here.
Okay.
Because it has a QR code, it will get scanned over there and then move accordingly.
It's actually very great to see that even the warehousing system is automated to such an extent where it kind of reduces labor a lot.
Actually, it was designed keeping in mind that we have to reduce the manpower.
Right.
Because when we are catering to such a big area, so requirement of manpower was huge requirement. So with the central conveying system, we reduced a lot of manpower.
And you, I'm sure, had, like managed to cut down a lot of cost as well.
Sure, we have cut down a lot of cost. Now I'll show you the area is over here, how deep it is. You can
Right.
see how deep it is.
I see quite some racks, 1, 2, 3, 4,
Lot of
and
them.
it's
And
numerous.
see the depth inside to the other wall.
Looks endless.
Yeah, it is too big. So from each level, he unloads the material
Right.
and gets to the delivery point. This is the delivery section.
Okay.
You can see a spiral conveyor.
Yeah.
So it is put on each level. There's a entry for the spiral conveyor. So they put it there. It rolls down directly and
Okay.
comes over here, and here it is then picked up as per the requirement.
Okay. So where does the loading start from for dispatching?
That's what. Once it is come, then they fix it on the pallet, this
Okay.
thing, trolley. Then
One.
it goes out for a dispatch.
All right. Sustainable energy, cost effective, efficient.
Many things keeping
Many
in mind
things. Correct.
and develop certain things. From here, if it is moved here with the
Okay.
shrink wrapping, completely stretching is done here. Then the pallet is, after stretching, is coming out, then moved out on the dispatch bay, where it is placed into the vehicle and moved out with the documentation and all.
So this is basically the end point of a finished product's life cycle.
Yes.
Well guys, with this it's a wrap. Thank you so much for tuning in, and I hope you enjoyed the entire A to Z process of Pravesha's packaging production process. Thank you so much for tuning in, and really looking forward to seeing you in the next episode. Until then, take care. This is yours truly, Rukhsar Heavy, signing out.